The Indian Army has worked out a detailed technical requirement for nationwide gigabit network, which is planned to be fielded as Army network for Spectrum. After detailed discussions and presentations with the Indian Army, and after having understood the functional requirements, our technology consultants have proposed a solution which is based on emerging networking technologies. This solution has 4 components: DWDM-based optical transport, carrier-grade data switching, fully integrated solution for end-to-end interworking of existing legacy network of the Indian Army, which are currently the mainstay for voice, video and data services. Voice telephony component which should cater for the migration from TDM to IP solution. After intensive discussions and testing with our experts, crack team and R&D engineers, it has been concluded that the requirements for the Army NFS has 2 technology options: Carrier Ethernet over MPLS, Carrier Ethernet over Provider Backbone Bridge with Traffic Engineering, or PBBT. Though MPLS is a good option for an IP backbone, it fails severely when there is a requirement for carrier-grade features like end-to-end resiliency, scalability, protection, service provisioning and management. Therefore, a need was felt for a detailed competitive analysis of these 2 options on an end-to-end basis.
As editor of IEEE 802.1 AG and Y1731, the ITU specification, I have been personally involved in addressing a key problem in traditional Ethernet, which is the OAM. In ITF, I have been involved with numerous drafts which have established the coexistence of carrier Ethernet with other technologies. In MEF, as editor of different technical specifications, the establishment of carrier Ethernet to provide carriage of different services has also been established. In DSL forum, as a contributor to TR101 technical specification, I have been involved in specifying the application of carrier Ethernet as an application for broadband networks. With all these different activities taking place, carrier Ethernet has really emerged as a strong technology. Finally, I have been involved in introduction and adoption of Nortel's provider backbone bridges in IEEE 802.1 and provider backbone bridges traffic engineering as a power activity in recent 802.1 activities. With so many different standardization activities underway, and the fact that many different standards have now been completed, and finally the fact that many different service providers are adopting and deploying wide-scale carrier Ethernet deployments, carrier Ethernet technology is real and here to stay.
There is a paradigm shift in the network design with respect to the capability of control plane and management plane. Typically, MPLS has been deployed by most of the service providers worldwide as a technology for the network core. However, Army solution requires commonality of traffic engineering and network control features end-to-end. Such an approach has not been tried by a lot of carriers worldwide. Hence, the Army decided to go for a detailed and deliberate POC at Army facilities. Nortel has offered its solution to POC by the Army, which is being conducted as per the directions of DG Signals. Highlights of some of the POC testing were: resiliency test. One of the key requirements of the Indian Army was ultra-fast traffic failover under 50 milliseconds. Nortel Solutions is proved to be capable of recovering under 50 milliseconds at all layers of the network. This did not affect any end-user traffic. The measured results by the Agilent N2X tester showed close to 20 milliseconds for path recovery, a figure which even supersedes the SDH recovery time. BEU integration and transparency test. Fundamental transport mechanism used by the Indian Army is heavily encrypted using bulk encryption units. No traffic is allowed to go clear text once it leaves the controlled network domain. A feature that requires meticulous transparency on the optical transport layer with clear SDH overhead handling and clock synchronization. Nortel demonstrated its capability to seamlessly integrate with the BEU and continue to offer all network features that is required for the network for Spectrum. Nortel's MERS 8600 provides native SDH interfaces with ATM framing at STM1 and STM4 speeds while continuing to provide next-generation carrier protocols like PBBT. Opera Metro 5200 provides transparent BEU connectivity over DWDM infrastructure. These specially designed hardwares preserve all SDH payload, overhead and unused bytes across the network. End-to-end quality of service. One of the mandatory functional requirements for the Army network for Spectrum was to provide ultimate quality of service for every traffic flow that originates and transits through the network. To this effect, Nortel engineers built extensive test cases to make sure that emergency services are absolutely prioritized ahead of less important traffic. All the tests were conducted with baseline traffic and network load already running through every network element. Tests were conducted with no QoS definitions. It has been observed that there are significant traffic losses during the congestion simulated by Agilent N2X tester. Tests were repeated with QoS definition on every network element, and it has been amply proved that despite completely congested link, prioritized traffic can pass through the network in real time. TDM Legacy Interworking. Nortel MSS has been used in the POC to provide next-generation TDM and legacy interworking with the proposed high-performance PBBT-based carrier Ethernet technology. Nortel MSS has been widely deployed in various defense establishments and have a legacy of very high uptime and features. With enhanced carrier Ethernet features available in the converged MSS platform, it is possible to connect existing voice services, ATM interworking over carrier Ethernet, PNNI, inverse multiplexing, end-to-end transparent clock transmission, and voice signaling conversion.
Converged routing and switching on the same